All right, so this is going to be number 8 from your review. And it's basically asking us to graph this logarithm. Now the catch here again is that we have not stipulated what the base is on that logarithm, so it's implied to be 10. Okay, and so just as I'm going to take this as an opportunity to also talk about the fact that like log base 10 is the inverse of the graph y equals 10 to the x. And so just as a reference point, you're going to get some points like 1 over, if I inputted negative 1, 0, 1, and maybe even 2, right? And as for x values into this equation, I'm going to get something like 1 over 10, 1, 10, and then 100, something like this, right? For the outputs. Now, for log base 10 to the x, okay, you're going to get the inverse of that. Okay, and so you're going to get 1/10 and negative 1. And you're going to get 1 and 0 and 10 and 1, and then you would have 100 and 2. So pretty much what's going to happen here is I'm just going to put the exponential on for reference, right? It's just going to be something like this. So very close to the asymptote or the x-axis. It's going to go through 1, and then 1 is going to be up here, right? So it's pretty steep. This will be our exponential, right? It's even. Okay, so pretty steep. That's the graph y equals 10 to the x. And so you'll recall, if I draw the line y equals x on here, the inverse of that graph is what we're going to call log base 10. Okay, and so what we can do is I'm just going to inverse those points. We're just going to plot these points that are here, basically, right? And so I'm going to get something like 1 over 10 and negative 1, so somewhere in here. Very close to the y-axis this time instead. And then 1, 0, and then 10 and 1. And that's probably all I'm going to be able to plot on here. So it's going to look something like this, okay? Let's see if I can draw this better. So remember, it's got to look like it's going towards your vertical asymptote in this case, which would be at x equals 0. Sorry. Okay, try not to have it deviate away. It's got to be looking like it's getting closer and closer, okay, without actually touching. So anyway, I didn't do a perfect job of that, but that's the idea. It should be getting closer. So that's the graph. Y is equal to log base 10 of x, okay? So then, if you take a look here, right, it's just our normal transformation work, right, that we've seen since grade 11 on a whole bunch of different functions. So what this says is, if I'm going to list out some transformations for you, right? So for the graph y equals negative log, I'm going to write the 10 in there just so we don't get it confused, minus 5 plus 2. What's going to happen here is this says this graph has been vertically reflected. So the purple one I drew. So that's a reflection over the x-axis. Then it's been horizontally translated. We're going to say right 5. Remember, anything on the inside is going to be opposite. Okay, and then I'm going to say it's been vertically translated up 2 units. Okay, so I'm just going to basically do that for that purple graph. I'm going to reflect it. So it's now going to be facing upwards. And then, so it's going to be somewhere in here, here, and over here, right? Those blue points. And then they all need to be horizontally translated to the right 5 units. So our 10 is going to end up off. Okay, but that's okay. It's going to be over here at 15 or somewhere. and then we're going to vertically translate it up 2 units. So this point here is maybe the only suspicious one. We're going to go over maybe another 5 units. 1, 2, 3, 4, 5. So basically right at the very edge of the screen and up 2, okay? So all those points need to go right 5 and up 2, right? So you can kind of see right 5 up 2 is going to take me to here. Right 5 up 2 is going to take me to here. And then the 15 is just going to be basically right off the graph, okay? So somewhere over here, pretty close. Okay, so it's going to look something like this. It's hard to do this with the, oops. Okay, it's going to look something like that. And then what we're going to do too is also put on some like a asymptote, and I'll do that in red. So we can clearly see, in theory, this thing should not go past this line here. Okay, it should get closer and closer, but never actually go past it, right? So this is the vertical line, x equals 5. Okay, I'm looking at that blue graph. Okay, the one that I will label. This is the graph y is equal to negative log base 10x minus 5 plus 2. Okay, and what we're going to say now is we're going to write, that's kind of the graph, and then in part B we're going to identify the domain and range. So for B here, the domain, so the domain is going to be everything except 5, right? So as long as everything except 5 and greater than, sorry, I should be more specific. So everything that is greater than 5. So we can kind of say that the domain here is going to be x can be a part of the real numbers under the stipulation or such that x has to be greater than, not equal to, because it's kind of an asymptote. It's not kind of, it is an asymptote. It's not going to ever touch it. It's going to get closer and closer but never touch. The range, okay, the range, we can have any value of y with the exception that, oh no, we can have any value of y. There is no exception for this one. Kind of see it's going in both directions forever. This one doesn't look like it, like the end behavior as x goes towards infinity. It looks like it's kind of not going to go anywhere, but or approach a particular value, but it's just going to go in the y directions, both y directions forever, up and down, positive, negative. And part 3 there, the equation of the asymptote. The equation of the asymptote is going to be at x equals 5. We wrote that on there, so there you go. Okay, so that's the graph. That's how you would navigate it. That's kind of a nice way to recap, you know, that balance or the relationship between the exponentials and the logarithms. Okay, so that's pretty much it for that. We'll see you in the next one.